Hello, superstars. We're going to be looking at lesson 7.4c. We're actually breaking up into 2 days. So on day 1 here, just follow along, be amazing. Remember, we asked you to memorize some of your perfect square roots. Because if you know those perfect square roots, then that will help you estimate your square roots of non-perfect squares. So for example, we know the square root of 64, but we don't know the square root of 60. So using this strategy, specifically for a number line, you're going to be able to estimate it to a decimal with the nearest tens place. Like way back in the day, we used to do it to the nearest hundredths place, but we're like, that's a little bit too challenging. So let's use it to the nearest tenths place. All right, follow along. You get your amazing notes out. Then we'll do a little bit of homework help, and then you'll jump into working on as many homework problems as you can before class is over, and then finish it up at your home. Here we go. Square root. Oh, you know that one. That should be like boom. Like you don't even have to know it. And you better not say 4. What's the square root of 64? Yeah, that's 8. So if you have those memorized, then it's going to be so much easier for you. We did notice, though, that unfortunately some students this year were not doing their memorization like we wanted them to. So hopefully you did. Square root of 54. Well, we do not know the square root of 54. So we're going to go ahead and start with the first part of the concept was, well, what is it going to be in between? So the square root of 54, we're going to go ahead and say, well, we can break it up, right? The square root of the following, and this would give us what we call an exact answer. Again, that was from your quiz. You should have rocked that using your factor tree, looking for your pairs. The leftovers go inside. Again, this is an exact answer. In high school, some of your problems are going to definitely ask for your exact answer. But some of them are going to want an approximate answer. So we're going to learn a strategy to help us figure out that it's about 7.3. So you're going to start off with that thought of what is it in between? Is it in between 5 and 6? Is it in between 9 and 10? So in other words, that'll help us find that front number, the integer part, and then we'll find the decimal part using our awesome strategy. So join me in our adventure working with a number line to help approximate. Now, the very first part of your homework is just to figure out what is it between. So we're going to say that the square root of 8, well, we know the square root of 9, we know the square root of 16, but 8 is not between a 9 and 16. Now, remember, these are not normal numbers. These are square root numbers. So we're actually going to say that the square root of 8 is in between our two perfect square roots of 4 and 9, which means that the square root of 8 is somewhere in between a 2 and a 3. And we're going to talk about the difference. Is it exactly in the middle, or is it a low, or is it a high 2? Because again, it's in between 2 and 3, so it's definitely not a 3-point something. It's going to be a 2-point something. So keep that in mind. Is it a low 2, or is it a high 2? Try one with me here. Square root of 57. What is the square root of 57 in between for your two perfect square roots? Well, we know the square root of 57 is in between the square root of 49 and the square root of 64, which means the square root of 57 is somewhere in between a 7 and an 8. Is it exactly in the middle? Is it a low or is it a high? Again, that's what we're going to have our journey today. But you got to focus on those ones that I circled there, though, because you got to know your perfect square roots to help you approximate to that decimal point. All right, let's try a few. Now, we actually have two strategies. Some students prefer one over the other. I do myself as well. So we're going to estimate, so imagine the square root of 11 in that little blank spot to the nearest tenths place. So the first thing we want to start off with again is thinking about what is it in between? What are my two perfect squares going to be that the square root of 11 is in between? Well, hopefully you're thinking about the following numbers. Go ahead and make a number line. It doesn't have to be perfect. You don't have to use a straight edge or anything. You can just use the blue lines on your notebook there. And we're going to say that the square root of 11 is in between the square root of 9 and the square root of 16, which means our decimal is somewhere going to be between 3 and 4. So a 3 point something or a 4 point something. All right, that's pretty much like we started on the previous examples. So you got to know those perfect squares. All right, let's go ahead and find the midpoint. The midpoint concept you will be using in high school for other thoughts, but we know that the mid or middle of 3 and 4 is definitely going to be 3.5. Now the question is, does anybody know how we got 12.5 for that part in the middle? The square root of 12.5. Well, it is essentially in the middle of the 9 and the 16. Even though it's square roots, we're just going to act and kind of behave like they are normal numbers. We can also say that the difference between a 9 and a 16 is 7, and the middle of a 7 is 3.5. So if I add a 3.5 to my 9, then I get a 12.5. Regardless, you got to find the middle of a 9 and a 16. Or maybe you can just add the two and maybe divide them. So 9 plus 16 is a 25, and half of 25 is 12.5. That might be easier for some students as well. But regardless, you got to have that middle. All right, now let's decide which side it's going to be on. We know the square root of 11 is, well, is it going to be on the left side or the right side? Is it going to be a low 3 or a high 3? We know that the square root of 11 is not going to be on the high side because we know the square root of 11 is less than the 12.5. So it's going to be somewhere over here. Is it in the middle of the two? I'm not too sure. Now, I personally don't do this method anymore. I used to do this method all the time. I'd say, okay, let's take half of half and half of half again. Now, some students are amazing at that, and they can do it very, very well. I'm going to show you my personal strategy on method 2, but this one is still really good. So in the middle of 3 and 3.5 is 3.25. So the middle of 9 and 12.5 is 10.75. And probably the easiest way to do that, again, is add the two numbers together, 21.5, and then cut that in half, which is a 10.75. Now we know that the square root of 11 is a little bit to the right. So what's a good estimate or approximation for the square root of 11? It's a little bit bigger than a 3.25, so we're going to say it's approximately 3.3. Now, some students rock with that. If you know how to do some mental addition and division, this is probably the strategy for you. If you struggle with the mental addition and division, you may want to try method 2. We're still going to get the exact same answer of 3.3, but I'm going to show you an additional method. Method 2 again. Starting off the same way, you're still going to figure out what's it between. We know it's between the square root of 9 and the square root of 16. Same start there. So we know it's between 3 and 4. You still want the middle. Oh, sorry, it's a little out of order. You still want the middle as 3.5, and the middle is the square root of 12.5. That tells me that the square root of 11 is a little bit less than the square root of 12.5. So that means I really have 4 options to choose from: 3.1, 3.2, 3.3, and 3.4. Now, the one difficult part about this method is it's really relying on guessing and checking. So do you want to guess 3.1, 3.2, 3.3, or 3.4? So you got to start somewhere. So for example, if we square a 3.3, because remember, that's multiplying it by itself. 3.3 times 3.3, so it's really just practicing some of your elementary multiplication. If you multiply it out all correctly, we would get some nice 9s. If I add it up, I get to 10.89. 10.89 is so close to 11, so we're going to say that it's probably that one. But if I were to check a 3.4 and I do all my good multiplication, I would actually get a number that's a little bit bigger than 11. So it's kind of like that Price is Right. Maybe you've ever seen that before. You want to get as close as possible without going over. So if I were to guess my answer of 3.4, then that would have been a little bit too high. If I were to actually guess my answer is 3.2 and I checked it, that would actually be a little bit too low. So the only drawback about this method, in my opinion, is you got to guess and check. So if you guess incorrectly, then you got to guess again. But I think most students, the majority of students, might like method 2. If you're rocking the A's and maybe even B level work, you might want to do method 1. Your choice. All right, let's try another one. Square root of 52. We're going to start off with that process of, okay, what is it in between? We want it in between two perfect square roots. So we're going to say the square root of 52 is between the square root of 49, which is a 7, and the square root of 64, which is an 8. So it's going to be somewhere in between 7 and 8. Now, some Superstar students will notice right away that a 52 is really close to a 49. So the middle, you may not even need to worry about the middle on this one because that 52 is so close to the 49, which means it's probably going to be somewhere right over here. Method number 1 again, you would cut it in half. Half of 7 and 7.5 is 7.25. You add those two numbers together, a little bit bigger if you notice, divide by 2. So for example, a little bit more mental math or paper pencil math there, which is why most students don't like method 1, but that's okay if you do. So notice this, 7.25 is 52.75, which means my approximation needs to be a little bit to the left this time. A little bit to the left would be 7.1 and 7.2. If you were to do the whole guess and check method, like we're going to see in just a moment, you would guess either 7.1 or guess 7.2, and you'll be able to find your answer correctly. Because if you guess 7.1, it'd be too low. If you guess 7.2, it'd be just right, like almost there. All right, so again, I like method 2. Let's see here. Same start. I know that the square root of 52 is so close to the square root of 49. So I know that it's going to be a lower 7 definitely. So is it 7.1 squared or 7.2 squared? Which again, you're practicing your multiplication skills. So you got to know that. And if you're not super strong at it, this is a great way to continue to get better. So if we do multiplication, we got 4, 14, placeholder. We have a 14, carry the 1 at the top, gives me a 50. If I add it up, notice how close it is to the 52. A 51.84 is so close to a 52, which is exactly what we want. 7.3, I don't even think we need to guess that one, but if you did, because some students, again, they might guess incorrectly, get us a little bit too big there. Oh, notice we're in a 53, and 53 is too big for 52. But remember, it's not really 52, it's the square root of 52, which is why we get approximate answer of 7.2. Now, it's an estimate, right? It's not as accurate as we could be using the good old calculator button, but we're trying to help you learn some great strategies to get you prepared for more Chapter 7 and some advanced Chapter 8, and then even in high school. All right, this one. Now, this one right here, a lot of students can just visualize it on the number line, regardless of which method you do, and you would know that the square root of 97 is so close to the square root of 100, which means my answer has to be so close to a 10, which means if you were to cut it in half, you would know that this time it would be on the upper side. Because the 97, square root of 97, is so close to the square root of 100. So it means it's going to be, for those of you who do method 2, it might be a 9.6, 9.7, 9.8, or 9.9. I think 9.8 or 9.9 would be a great guess to check to see how close you can get to 97. Remember, we don't want to go over. If you're going to do the more accurate method like this, you got to be really good with your addition and division. So it looks like we're a little bit bigger, according to this method, than 9.75. So it's either a 9.8 or a 9.9. Again, you want to get as close as possible, 9.8. But for this one, for me, it's a little iffy because some students might just kind of guess in a way, which I know an estimation is supposed to be like an educated guess. But if you were to do the method 2, you would do 9.8 times 9.8, and you would get really close to 97. So let's actually try 1 or 2, maybe a few more. Let's see on your assignment. So go ahead and pause the video and pass out the worksheet, please. All right, welcome back. Let's go ahead and try a few problems. The beginning ones here, it says, what is it in between? Let's go ahead and do number 2. We know that the square root of 125 is in between the square root of 121, which happens to be an 11. So it means 11, this has got to be a 12, which means it's between the square root of 144. So the square root of 125 is in between the square root of 121 and 144. Notice how the square root of 125 is so close to the square root of 121. That means our approximate answer, when we get there in a moment, is going to be a low 11, like 11.1, 11.2, and so on. All right, so let's try, let's see here. Yeah, let's try this one. The square root of 85 is going to be approximately what value? So let's go ahead and make our good number line. We know the square root of 85 is going to be in between the square root of 81, which is a 9, and the square root of 100, which is going to be a 10. This is going to be a 9.5. But notice the square root of 85, yeah, that's going to be way over here. Which means it's definitely going to be a low number. I don't even have to worry about that middle because the distance is so great there. But for those of you who were trying to figure out the middle, remember it is 100 plus 81, which is 181. And then we got to divide it by 2. Well, half of 180 is 90. So this would actually be a 90.5. So it's going to be somewhere over here, a little bit lower, maybe a 9.1, 9.2, 9.3, 9.4. Now, I don't think it's a 9.4 because that would be really close to the square root of 90, and there is some distance between the 85 and 90. So I'm thinking it might be a 9.2 or a 9.3. All right, so I think I'm going to do method 2 personally. Again, that's my preference. If you want to do method 1, go for it, which you would take half and things like that. So I'm going to go ahead and see what I get when I square a 9.2, which again is multiplying it by itself. My goal is to get as close to the 85 as possible. So let's see, 2 times 2 is 4, 2 times 9 is 18. Placeholder. 2 times 9 is 18. 9 times 9 is 81, plus the 1 is 82. When I add it up, sorry, gonna go into the other part, I've got a 4, a 16, a 1, 2, plus 2 is 4, 8. So I have an 84.64, and isn't that super close to the 85? Yeah, so that's why I like this method the best, is because I do a guess, I check. If it's good, I got my answer. If it's not, then I have to try and adjust it. Maybe I can make another guess. Maybe I can make an educated guess after that. But again, that's why I like method 2 the best. All right, let me try one more. Let's see here. Oh, that one's too easy. Some of you just know it looking at it. Let's see. Okay, let's try the square root of 61. Again, the strategy is to make a number line. That's a weak number line, Mr. Mario. Let's see here. I'm going to cheat and use the created one. Nice, that's beautiful. I think I forgot to officially welcome Miss Fung's class to our virtual learning here. So welcome. Hopefully you're participating well, enjoying your time. All right, we know that the square root of 61 is really close to the square root of 64, which is going to be our 8. And so that means this is 7, which is the square root of 49. The middle is 7.5. Again, add the two together, so it's almost a 50. So 50 plus 63, or really you can just do your old school 64 plus 49. Gives me 13. Gives me 10, 11, 113. Now remember, the middle is going to be the 113 divided by 2. So 2 and 1, no. 2 and 11, yes. 2 times 5 is 10. 2 times 6 is 12. So again, that's how you find the middle number, which is how you get the 0.5. So we would say the square root of 56.5. But I'm not too sure if we even really need to do that, at least on this one, because we know that the square root of 61 is pretty close to the square root of 64. So we definitely knew already that it was an upper answer. And by upper answer, I mean, again, on the right side of 7.5. So that means our 7.6, 7.7, 7.8, and 7.9. Now, for method number 2, again, that's the way I'm going to try it. I'm going to try and guess. Now, remember, if I guess and I check it and it's too high, then my answer is probably the one that's a little bit lower. But if I guess and check and it's too low, how many options do I have remaining that would be the upper ones? So let's see. Usually it's best to guess one of these two here. So I'm going to try and guess 7.8 this time. Again, if you want to do method number 1, you'd be a little bit more accurate. You got to do a little bit more of addition, division, and things like that, but it's a great strategy. Some students can do that really quickly. So let's see. 8 times 8 is 64. 8 times 7 is 56, plus 6 is 62. Placeholder. 7 times 8 is 56. 7 times 7 is 49, plus 5 is 54. 4, 8, 10, 6. Oh, look at that. Yeah. I was really tempted to try and guess 7.7, but I'm really glad I tested 7.8. Because 7.8, when I multiply it by itself, I get so close to the 61 like I wanted. 7.8. Sometimes we get lucky like that. Because again, it's just an estimation or approximation there. An educated guess, but you got to put some thought behind it to help you out. All right, so you got some on the front like that to do, and then on the back side, remember you've got some review problems, some graphing equations, slope-intercept form. Some students I've noticed in my class have been actually using their notes to help them out. Let's actually do 17 just real quick. It says write an equation in slope-intercept form. So remember, I need the slope and the y-intercept to be able to do that. The y-intercept is going to be 0 something. In fact, I notice it is right here on the y-axis, which is 0, 1. Ooh, it's -1. And then I notice it's going uphill, which means it's a positive slope. So let's go ahead and travel up the line until we can find an additional good point. No, no, no. Yeah, right there. So using a little right triangles are going to be super important in chapter 7. My rise is 1 and my run is 4. 1 over 4. So my equation in slope-intercept form, remember that's the y equals mx plus b. I'm going to say y is equal to 1 over 4x, and then it's going to be a subtract 1. All right, superstars, you're going to be amazing. Do the best that you can. We're going to try some more of this tomorrow. So let's ask questions as needed. Have a great day.